Hello students, welcome to video lesson 7.3. We're going to continue our discussion in this video about similar polygons, but we are going to get a little bit more specific and we're going to talk specifically about triangles, okay? Because we have three shortcut ways to prove that two triangles are similar to each other, all right? So in our last video, we talked about the definition of similar polygons. Right, and the definition of similar polygons, or remember the things that we said had to be true about similar polygons was that their angles need to be congruent, right? All the corresponding angles from one shape to the other have to be congruent, and the sides have to make equal ratios, right? Sides make equal ratios. So those two things needed to be true for similar shapes. And once we prove that triangles are similar, that those things are all of course true, but there are shortcut methods to prove that triangles are similar, all right? And this only works for triangles, but we'll go through these three. Your book calls them postulates and theorems, things like that. We'll probably just shorten it to these abbreviations, but we're going to talk about how can we more easily prove that two triangles are similar to each other without needing all three angles congruent and all three sides in the same ratio, all right? The first and easiest and best way to do it is something called the angle-angle similarity postulate, okay, which says if two angles of one triangle are congruent to two angles of another, the two triangles have to be similar. There is nothing in here about side lengths making ratios, okay, so we don't have to make any proportions or anything like that. It's just two angles equal to two angles. Now, we've talked before about two angles being equal to two angles in a triangle, right? Hopefully you remember something called the third angles theorem, right? So because these two angles are congruent to these two angles, we know by the third angles theorem that the third angles in the shape, T and P in this particular example, are also congruent. So you can think of this as angle, angle, angle. Okay, but we don't actually need the third angle because if we have two of them, we guarantee we have the third one. So that's why we shorten it just to angle, angle. Okay, so we call this the angle-angle similarity postulate. And you notice we have this abbreviation AA and then the squiggle for similarity. And anytime you have two triangles that have two congruent angles, it guarantees that the triangles will be similar and therefore all the side lengths will be in equal ratios. Okay. We don't need to know anything about the ratios prior to proving the triangle similar because we have this shortcut, all right? So anytime the angles are the same, then the side lengths will also be in the same ratio for triangles only. So what you're gonna be asked to do in your homework is you're gonna be asked to look at triangles and decide, are these triangles similar, okay? Are they similar? Are they not similar? And how do you know? Of course, is gonna be, we're gonna use our shortcuts. So if we look first at this example here, RSW and VSB, the one thing I want you to notice is we have one pair of angles that is given to us as congruent, right? Angle R and angle V are congruent because they're 45 and 45, right? Now we don't know about W and B. These angles are not marked or in any way to show us that they're congruent. So the question is these other angles, are these angles here congruent, right? This angle at S and then this angle at S in the other triangle. Are those congruent angles? Well, what kind of angles are these? They're vertical angles. So vertical angles we know are congruent, right? So absolutely yes, these two angles are the same. So because I was given that V and R are congruent, and I can see vertical angles here and here that I know have to be congruent, the answer is absolutely yes. These are similar triangles by angle, angle similarity, okay? Because angle R is congruent to V, angle S on this side is congruent to S on that side, all right? If we look at this other example, we have triangle JKL and PQR. Again, angle L right here is marked as 70 and angle R is marked as 70. So that's one angle that's congruent. That's nice. But in terms of, the order in which these points come, I would be looking to match up J with P. So I know J is 30, but I don't know angle P over here, right? I don't know that one. So can I find angle P? Or in the other case, I would need K goes with Q. I know Q is 85. I don't know K. Could I find K? Well, the answer is yes, because in both of these triangles, I know two of the angle measures, right? And when I know two of the angle measures, I can simply take away those two from 180 degrees, and that should give me the third angle, right? So this one here, I would need to do 180 minus 30 minus 70, right? That's also known as 180 minus 100 because the other two angles added together make 100. So 80 degrees. So angle K right here has to be 80 degrees, right? And so now we should be able to see that these two triangles are not similar because angle Q is 85 and angle K is 80, right? And so these are not the same. So these triangles can't be similar because the angles aren't the same. And remember, we said the angles have to be the same if they're going to be similar. So we would say no. Angle K is not congruent to angle Q. Okay, they're just not the same. We could also find out that this angle P over here is 25 degrees. Okay, and that's not the same as 30, of course. So these are not similar triangles. A couple more examples for you. Here we have two triangles, and this one has, well, they both have a 90-degree angle marked, which is nice. So we know one angle is the same. This one has a 39-degree angle, and this one has a 51-degree angle. So we're tempted to say, well, those aren't the same. 39 and 51 aren't the same. But remember, this is another situation where we can find the measure of the third angle, right? Because, for example, in this triangle, we would do 180 minus that 90-degree angle, which is going to give me 90 degrees, and then minus 39. Well, that's going to become an 8, 10. 10 minus 9 is 1, 8 minus 3 is 5, 51. So this angle right here is 51, but that's the same as this angle, right? So I have 90, I have 51. So yes, by angle, similarity. And of course, we would need to show this work as well to prove that these triangles are similar. And then this example over here is a little bit trickier, but it goes back to something that we looked at a long time ago, back in chapter, maybe it was just chapter 4 or chapter 3. Isosceles triangles, right? Isosceles triangles, remember, have base angles that are congruent to each other. So in this particular case, this angle is 68 degrees. This angle is 68 degrees. So if I add those together, I get 120 plus 16, which is 136, right? So if I did 180 minus 136, I think I would get 44, right? 44 degrees. So this top angle up here must be 44 degrees, right? Because the isosceles triangle had to have two 68s. I minus those from 180, I get 44. Is that going to be the same as this triangle over here in terms of angle measures? Well, no, because at least one of these would have to be a 62 because they told me this angle here in that triangle is 62. I don't see any 62s over here, so I do not have congruent angles. There are no congruent angles, okay? So this angle-angle similarity, as I mentioned, is the easiest. You only need two pieces of information, but sometimes we have to do a little bit of work to find those pieces of information, okay? The other two ways to sort of shortcut prove that two triangles are similar sound a lot like our congruence theorems from back in chapter 4, okay? But they're similarity shortcuts as well. So this first one is called the side angle side similarity shortcut. And basically what that says is if I have two side lengths that are in equal ratios with each other, right? So this red side AB over QR is the same as AC over QS. If that's true, and the angle in between those two sides are congruent, right? In this case, angle A and angle Q, then that's enough to know that the whole triangles are similar to each other. Okay, I don't need to know the measures of these other angles, and I don't need to know anything about the third side. Okay, so I can prove that two triangles are similar by just using two sides in equal ratio, right, making my proportion, and the angle between those sides being congruent. All right, and then the other shortcut is called side, 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 and this one doesn't use angles at all. Okay, we don't know anything about the measures of any of the angles, but if we can show that all three pairs of corresponding sides make equal ratios, in this case AB with QR, AC with QS, BC with RS, if we can show that those are all equal ratios, then we don't need to know anything about the angles. We can simply say, okay, yes, these are similar triangles. Now, once they're similar, then of course we know all the angles are the same, but we're not using the angles here to prove or to show that the triangles are similar, all right? So again, we're gonna be asked to look at triangles and decide if they are similar or not, thinking about these two options. So when you see a picture like this where you have sort of side lengths marked for all three sides of both triangles that they're asking you about, you should be thinking immediately side, 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 and you should be thinking equal ratios. Okay, I'm gonna try to make equal ratios. Now it's important that when they twist and flip the triangles around that we always match up the shortest side with the shortest side, the longest side with the longest side, and the middle side with the middle side. So in this particular case, if I look at my two shortest sides, I get 6 and 9, so I go 6 over 9. And then my middle sides are 8 and 12. And then my longest sides are 10 and 15. So each of these can be reduced, right? I can divide 6 and 9 both by 3, and I get 2 over 3, I think. 6 divided by 3 is 2, 9 divided by 3, okay? I can divide 8 and 12 both by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. I can divide 10 and 15 both by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. And hey, look at that. I have reduced ratios for all of these, and they're all the same, right? So are these two triangles similar? Yes. And then you notice it says write a similarity statement. Okay, a similarity statement for these two triangles. So again, similarity statement simply says this shape similar to this shape, and we're very careful about the order that our points come in, right? So I'm going to start, when I write my similarity statement, maybe with the thing that looks like it might be a 90-degree angle in each one. So I'm going to start with T, and then I'm going to go to the shortest side first. So that'd be the 6, so I'm going to go TSU. And then similar squiggle, triangle V is what looks like might be a 90-degree angle. The shortest side gets me to X, and then W, okay? So that's my similarity statement. And how did I know they were similar? By side, side, side similarity, because all three sides were in the same ratio, okay? This other example here has some overlapping triangles, okay? So we have a small triangle here, KLP, and then we have a bigger one, KMN. So when we have overlapping triangles, what we used to do when we were proving they were congruent is we would sort of write them separately, okay? So that's what we're gonna do here as well. We're gonna sort of draw these two triangles separately. This is going to be KPL, so that's 8, 12, and I don't know that one. And then I have the bigger version. And this is KNM. Okay, so now the whole side length from K to M we have to recognize is not 2, right? It's actually 10. And then K all the way to N, well, that's 15, right? That's 15, okay? So I only have 2 sides marked here, right? Only 2 sides marked. So I can't be using side, side, side to try to prove that these two triangles are similar to each other. I have to use side, angle, side, which means I need to find an angle that's the same for both of these, right? Well, the good news is if we sort of look at the two triangles I've made, angle K is in both of the triangles, right? This angle right here. angle K is in both of the triangles. So of course that angle is the same in both triangles because it's itself, right? That's something that if we were writing a proof, we would use reflexive property. Angle K congruent to angle K. So that angle is in between these two sides that I know the length of. So if I can show that those are equal ratios, those two pairs of sides, I will have side angle side similarity. So I'm going to write myself sort of these two ratios, 8/10 and 12/15. Okay, and the question is, are those the same? Well, remember that another way to check and see if ratios are the same is to just do your cross multiplication and see if you get the same thing. So if you do 10 times 12, you get 120. If you do 8 times 15, 15 times 8, 0, carry a 4. 8 times 1 is 8, plus 4 is 12, 120. So yes, these are in equal ratio, right? So I can say, yes, these are similar. And I will, okay, so it's by side angle side. That's a terrible squiggle, but you get the idea. And now I'm going to write my similarity statement, right? Triangle, I'll start with the K, and then I'll go maybe on the longer side first, this time KPL. Similar squiggle to triangle K. Longer side gets me to NM. Okay? So we're looking at triangles. We're trying to analyze, what do I know? What can I figure out? And does that give me enough information to prove triangles are similar? If you have any questions about these three shortcuts, angle-angle similarity, side-angle-side similarity, or side-side-side similarity, please do reach out to me. Let me know, especially if you're struggling with sort of your practice problems, deciding if triangles are similar or not, and proving that with some math. Do please reach out to me. I'm always available for you. Otherwise, that's all I have for you right now, and we'll talk to you soon.